Bobscheme. Bobscheme is an awesome Lisp scheme implementation written in C# in .Net, on .Net. And the code is JSON. And it's Bobscheme. It's really, I'm gonna throw it away after this and burn it and never think about it again. But here's how far I am. I have a .NET program. When I run .NET program without args, I do the magic thing, the magic Lisp thing, while true. I'm gonna prompt the user with something, and I'm gonna wait for the user input, and then I'm gonna call the magic functions read, eval, and print. Read takes a string as input, passes JSON into these awesome J tokens, and then it calls eval, which is my metacircular evaluator here. Metacircular. And I have eval apply. Works for primitive operators, of which I have one. And the last thing I was playing around with in Bobscheme is that whoa, holy shit, it's text okay. Last thing I was playing around with was saying, is this the string foo? Yeah, right now this is the string foo. Yeah. And this is supposed to be the symbol foo, yeah. So that would look it up in the environment, that's not implemented yet. Symbol lookup. But function application with a primitive is implemented, so this is the JSON array. And that's of course Lisp, I read it as Lisp data, so I'm returning here, this is an application, and then in this part of the eval I say, give me the operator, I eval the operator, this eval is a primitive procedure, and then here I say operators, which is a list, 1, 2, 3, eval the sequence, which is in this case all self-evaluating stuff, and then I'm evoking here primitive procedure, so apply returns 6, and eval then in the end returns 6, and I'm printing 6, so that's what is happening here, and then when I say 1, 2, I can have nested function calls already. And yeah, right now I have this colon here in front of symbols, but I decided I think I don't want to have that anymore. And yeah, now you have a program running back and forth. I'm thinking about this thing called a REPL, read eval print loop. I think this as simulating conversation. I'm thinking about this lately. This is sort of like the most simplest sheet of you talk to the program, and the fundamental thing is the program is running and the program asks you what to do next. And you say, what is next? You say the string foo is next. And yeah, in a mature Lisp, if I have more steam, you will be able to say define the symbol foo to be 10 or something. Here's ChatGPT coming up with examples, define p to be something, but it's not implemented yet, so we'll say that define is not a function. Amazing, works, right? Errors are part of, errors. Yeah, we should say try. I really should say try, LSP mode, yeah, LSP mode, do it. That's the kind of stuff where I don't care so much, I just, if I think I need it, then I pull LSP mode. Yeah, and I don't even have this by default in my config. A few languages. Catch, how does this thing work? Like this. Console, error, right, line. So yeah, C# is not my, it's not where my Emacs usage is optimized. My Emacs usage is optimized in modifying Lisp and Clojure code. This is where my configuration time goes. So yeah, I'm moving around those eLisp forms like this. Is one thing about the parlance. Once you get to have the feel of the power of the parlance, I get structural editing for free. Yeah, like I'm editing on the level of this if statement, right? Like if I'm here and I say convolute, then I say, I decided that this whole if statement should sort of be outside here, like that here is the if. So like show me how you do this in your language. I have a button to publish that. So yeah, already works. Already is there. You have, and it's simple. It's a simple language. When I was first looking at Lisp, I didn't care so much about the parlance. I don't think I was off put by this. I remember looking at those symbols and thinking about, oh, that's sort of the meaning. And I mean, who looks at that? It's like looking at the points in sentences of a language or something. And to me, it's obvious. You look at the names of things, and that's where like you get some of the meaning, even if you don't know the language at all, right? So yeah, ChatGPT can already write Bobscheme, of course. I wanted to say try catch and then I print, so that when we're on the REPL, that who's an error. But this is an error, yeah. Yeah, this should be an error, okay. Now I'm printing out an error, yeah, that's good. Okay. this one's a read error. That also makes sense. Okay, so now I want to play around with this, and like there's two things I want to achieve. One is I want to be able to define, so I want to have a global environment, and I would like to have lambda. I would like to be able to have compound procedures. Like you don't want to code like putting these columns everywhere. Just I thought it would be too retarded. So this here would be an error, and this would be, I'm gonna say like this. It's a little bit like a Lisp quote, but in this case I'm saying, this is now the string. This is the string. Hello. This is just a bit like a normal string kind of thing. So is symbol, that is when this thing is a string. And not is string. Oh, hey, one sec. I have hacked this. Okay, I don't know why in C# mode some packages doing some garbage. Usually I would, if this was my Lisp setup, I would just go and figure it out, and I wouldn't even do anything else. But since it's just my C#, whatever, let's get shit on whatever Emacs thing, I just quickly shit out this hack. I don't know. I typed this and they didn't put the electric power in there, so I just went and dominated C# mode map. Insert the second power and then be done with it. Okay, so is string, that takes a token expression, and then I'm gonna say it's a string and it's a string and then it starts with this quote, and I think then I'm good for the moment. exp, oh, I'm gonna call this exp everywhere. Okay, is symbol, it's a string and not a string. That is okay. Okay. Here's an Emacs thing. Maybe you don't know. Oh man, how did I type it? Like this? Yeah, okay. You maybe don't know, but here, for example, I have electric parents or something. So the way this thing works is that there's some. Is there? Yeah, there's different ways to make it work. You can add a post command hook or post self-insert hook as well. Then you could check that the user just type a parent and then you add another parent. Or you could overwrite the command. I think that's what they did. No, that's self-insert. So that they must, I think in order to get this electric done, help variable post self-insert hook. Oops. A help variable in this buffer because it's a local self-insert hook. Some compiled functions. That's of course a bit hard to read. If you see something, you see some anonymous compiled functions. Local buffer, so in C# mode or C mode or somewhere somebody's setting up post self-insert hook. I'm not gonna check this now. I could like now get it out by saying debug on variable change. Debug on, not debug on variable change. What's this thing called? Variable change. Debug on variable change, yeah. Trigger the debugger when a variable is changed. That's one of the things you think, what the fuck? Like, I want this in my program sometimes. I mean, if you program with state and you have variable, I remember when I was doing game dev with C# or something, I think this would have been the thing sometimes. And Emacs just has all these primitives built in, or these debugging things built in. You just, I guess, don't know about them for a while. Because there's so much to figure out. There's so much to find. Another one you might not know is trace function. That's the one I use quite a bit. It's a little bit, it's kind of similar, sort of like you set up a watch and then you get feedback whenever something happens. You could trace function self-insert. It's gonna be, honestly, self-insert, command, trace function self-insert. So now you see every time I do something, the self-insert command is being called. So you see this one is F, and T is 3 times O. I see it from the character codes and starting to read the matrix. Untrace function. This. Boom. Okay. So you see that you live together with the program. Really. Once you have a program that is living, that is running, you can decide. And like, why does it work now? Because everything is so dynamic. There's like the thing where we called the variables. That is the data structure itself, and it has some semantics. Where you can say add a watcher to me, something like. I mean, the same way you have classes in your normal languages or in your mainstream languages. You have a class that takes some watcher or something. But here, this program is about the language constructs, the variables, the functions, and so on. And so everything is built to make these variables and functions operations really nice for the user. So It's like the program has all the stuff that usually you have in the compiler that is usually hidden to you, and in Lisp it is part of the program that you have, and you have the ability to take things from the compiler, or yeah. Importantly, there's a split between read and eval, which is two things. It's also two things in compiled languages or normal languages. It's just that they glom it together into one compiler and give you no ability to leverage read. If I say read 10, it would be the string 10. Yeah, it would be the string 10, this would be the number 10. And if I would eval, I could read a list, and then eval, and it would be 6. And this could be in a loop. CL loop. How do I say? I don't forget, while true? No, while t. That do. No, what's I do? Yeah. Again, that's a readable print loop now. Only I'm not printing anything. Yeah, true. So now I printed something, and I could say define something that for foo to be 10. Yeah. And now I'm gonna quit out of the loop, and that actually was all the same was still the same program. New readable print loop inside the same program. Never restarting. It's just in a lookup somewhere. There's a new thing called foo with 10. It's really so simple. It's so simple. The idea is so simple. Just put the language into the dynamic part of what your program is about, and then like magic happens. Really, the whole thing opens up to a complete new level of what you can do. Can't say it otherwise. In Emacs, you can say by default Ctrl Q, and then you type any key, and that's called self-insert command instantly. Self-insert command is the thing that takes whatever you type on the keyboard and inserts it as a character. And now I press a single quote and I get a single quote. So whenever you have special characters, special things, even for example, comma for me. Comma means something for me. That's like what? Comma. Yeah, whatever. Comma is. If I describe comma, that is meow keyboard, right? If I say comma, but I can say Control Q. Oh fuck, forget it's muscle memory for me. Yeah, Control Q. Yeah, comma. Yeah, that would also insert. Would bypass everything else. Yeah. Sometimes you just need to insert. I need that sometimes for Lisp when I'm yeah, this for example. When I want to. Yeah, okay. When I want to insert a bracket pair, that's fine. But yeah, there's cases where you want to just, for example, in a ragged sphere, you want to insert a single square, for example. It sometimes happens. And then you don't know how to do it, and you feel like you're super clunky with Emacs or something. But it's only because you didn't know that Ctrl Q self-insert is a thing. So there's answers for everything. Everything is available for complete smoothness. So never think you can't be more smooth. Especially if there's something that is obviously clunky or something. Maybe you don't know a concept yet. So yeah, don't give up. And I did this because of this part. Okay, so now is string. Okay, that works. I guess as yeah, is symbol. I'm gonna be whatever I did here. If is string expression, then it is also self-evaluating. To object. Yeah. I'm gonna say because I need to. Yeah, this function here. I'm gonna say here's a string value. If it's a string, then pop the first thing. Yeah, this is good. String value. If is a string expression, then return the string value expression. Okay, let's return the value of this token as an object. If it's the empty array, it's nil. And then I have this thing. If it's a symbol. Primitive operators, yeah, I want to get rid of this and put this into the environment instead, and then if it's an array, that's the application. Okay, so does Bobscheme still work? I like saying Bobscheme. It's just have fun. Foo's unknown. No, that should be. Ah, yeah, that's true. Yeah, that's correct. And then foo with the quote. That's the string foo. Nice. Okay. And Dotnet run with hello JSON. That is the hello. That's our hello world. This is hello world in Bobscheme. Yeah, this hello world in Bobscheme. I like it. It's kind of concise. And maybe you also understand why this is a hello world in Bobscheme, because when I run Bobscheme on it, I print hello world, right? It's the program. It's good. That's what is required of hello world. It's just that we don't express so many things about the operation of the program, but we express more things about the ideas of what the program is, that we get this condition here. this is the most concise hello world compared to all languages. It's one character more than Clojure. So yeah, Bobscheme is fucking bloat. Bobscheme is so fucking bloated, man. Hello world is fucking one character more than it needs to be. But yeah, it's because I make my life easier with the symbol type and the string type. 36, correct. Yeah, Dotnet run, that's the better. What is the next piece? Next piece is plus. This is quite an achievement for me. Wow, I don't need to compile. I can program and I don't need to compile. Isn't it the best thing? The worst thing about programming, compiling? But for me, this is just the worst thing. Waiting for something to happen. It's literally like, wow, I stopped thinking, now I was thinking, and now I'm not thinking for a while, and then why do this to myself? Like, and why wouldn't it be like the most painful thing is fixed in the best language that there is? Like this, this, Emacs, and this, oh, yeah. Here's my Clojure scratch, here, yeah. This, yeah, the fact that I can make a variable, and it works. I just say to the computer what I need, and it's, yeah, you just do it with every single piece of the program. But this is also other videos, I suppose. But yeah. Okay, so environment, I'm thinking things will be less painful if I have the immutable, yeah. Maybe then I don't need to think so much about keeping things, about fixing everything. And then, oh, how does the immutable work? Okay, I'm gonna say there's a global inf. Okay, no, so now I need to think for more about what I needed for the anything for the global inf. Okay, so global inf is a lookup from symbol to values, which can be anything, including primitive operators, other functions, compound procedures, and then of course J tokens, expressions, and yeah, primitive, yeah, whatever. It's everything. Other symbols again, and then. Okay, so that's the global environment, and then I need local environments, which you can build either by function application or later, maybe if I do it in a special operator called let. Okay, I'm gonna try foo. Okay, and then I'm gonna print. Oh, I hope this prints well. Oh, that's the cancer with these kinds of not data-oriented programming languages, where things are oriented towards opaque objects. That's really a shame. Oh no, there's a slider. Fuck. Do it. Yes, I cancelled it. Fuck. It's on me. I was impatient. It was blocking my screen. Here. Bobscheme, dash, yeah. Okay, Dotnet run. Okay, that's a dictionary. I was guessing it probably doesn't print. But that's fine. Set item that didn't throw an error, so okay. So you can like sort of override. Yeah, that's the semantic I would also want from this. Okay, so now I'm gonna do for each I need to say var here, I think. Key value pair key. I'm gonna augment the global env value. Okay, cool. Maybe I make a function. Maybe make, yeah. That would be interesting anyway. Yeah. I'm gonna go meta. I'm gonna add a primitive operator called print_env to interact with the environment, and that takes a list. Yeah, which is an empty list. It should be an empty list. And then I'm gonna global env. So this turns out great. Value, print the value, and print the thing, and then print around element key. Okay, do this and return an object. Yeah, it's print env. Okay, this would be semi magic for me right now. If that would just work right now if I could actually say printf as a Bobscheme function application. Wow, yeah. Ah, yeah, I'm really close. Oh, yeah. Ah, yeah, it works. Okay, so the thing is, like, it worked correctly, so it's kind of nice. So that was semi-magic for me right now. I mean, yes. Then the fact that I'm writing my own language right now and I'm implementing operators, that's, yeah, I'm feeling emotionally different right now. Oh no, yeah, that's so garbage. Yeah, this is good enough for Bobscheme. Yeah, I'm gonna say I'm gonna do keyboard pair value to string, and then how do I say is func? Yeah, I'm gonna say if it's a function, then I'm gonna say primitive. Yeah, I'm gonna do it all caps. Yeah, something like this. Something else. Yes, procedure. Yeah. That's. I want to do this in my life. To be able to have my own language where I say, here, this is how you print something in an ugly way. Okay. Oh, what is this? What do I print? So I print. Nothing here. That doesn't do anything. Oh. Passing value D was. What doesn't pass value? What are you talking about? Oh. So. Okay. And this I can read whatever. Value you want. Yeah, you want this reader exception, I suppose. Yeah. I'm gonna say try. Catch exception. Console error write. Read error reading. A message. Yeah. Oh, this is so much better. Okay, try, return, catch. Yeah, when you read and it doesn't work, what should happen? I log something and then I throw. Oh, this is rethrowing call exception changes stack information. Oh, I should just throw. Okay, that's a detail. Okay, you type something that's not JSON, like foo. Error reading, yeah. But then I don't need this whole garbage anymore, right? But still, I want to. Oh, whatever. Yeah, catch. If A is not. Is this even what I need? Yeah. It's completely retarded, of course. I'm gonna actually swallow some stuff now. I'm not gonna do that. If I throw in eval, for example, or in print even. No, I leave it like this now. Okay, error reading, unexpected. That's actually not bad, I think. It's good. No, prints like this. It doesn't. I did this wrong. No. It's so painful to be wrong about this, man. You need to compile it again. Oh, list function. That was how unexpected. I make typos as programmer or something. Type check also doesn't help me because. Admittedly, because I'm not using their type idea of how to use it, but yeah. Oh yeah, primitive procedure, okay. Yes! Alright. So now global env. I can already print. Oh, the screen key thing stopped again. I'm sorry for you, it wasn't enabled. It doesn't need to be this big. Okay, so now you look up an environment, There should be a function called okay, so the first thing is that both eval and apply have always an environment as immutable dictionary from string to object env. Okay. Now stuff is happening, my friends. It takes an env, or we need to. Wait, why do I do this in Rider? I'm gonna try. Emacs. Maybe I'm a little bit more comfortable. Okay, so this eval. This doesn't look like this anymore. I need to say. Oh, that's the kind of shit. I mean, how many fucking parentheses do I have here? I have less parentheses in closure than I have with this stuff. Seriously. No. Okay, eval the operator env, eval sequence is an env, so apply takes an env, and broken, oh yeah, here's some primitive apply, doesn't use anything with env yet. So I'm not, you notice maybe I'm not jumping so much to the beginning and end of things, and the reason for this is because I'm just not used to that, as I would do that. But I'm very much in this view I have a different set of key bindings to achieve. Going to the parents, for example, and then killing one, and then erasing some, and then copying some, and then moving them like inside each other or outside of each other, and deleting them, or being here and then being here, selecting some, and growing on one side, or growing further, and growing like on each side or something, and deleting something, killing a line, and then moving around. Usually like this, like from either side, sort of. Or also when I kill to the end of the pattern, for example, so that the paths are always balanced, which is it's crazy. The moment I'm not balanced, I'm completely disoriented, because usually all my commands just balance the patterns. So yeah, that's why I'm the clunky. I modify this Csharp code here, but yeah, it's not much left. I'm almost done with what I want to do with Bobscheme, I think. So here, global env. Yeah, that's fine. I mean, I'm gonna. Oh yeah, wait. That will be global env. Yeah, will that work? That's fine, because I'm not defining global env to be read only, right? I'm allowed to. Does that work? No, that doesn't work. What am I thinking? No, here I call it eval with global env. Maybe I need. Well, I mean, for global env I need update semantics, not by definition. It's like it's the one place where you. But I say global env. Yeah, in every loop I say global env again. Yeah. So I do take the new value if I overwrite the variable, which I do. So then eval has the new env again. Yeah. Should be good. And when I'm inside one Bobscheme form, then I can I can accidentally modify the global env further up, but it's actually sort of a side effect. I'm not even entirely sure if it will work every time, because maybe sometimes you are deep in an application, or yeah, it might be weird. But yeah, that's not this one. Like, you shouldn't modify global env anyway. You shouldn't define. Like, I know scheme has like a way to say, oh no, I say local functions or something, but I don't do that. I tell you should use let instead. And define is really a side effect. You are modifying the global env. So yeah, it's like the one thing when in scheme you introduce the dark side of having global state and stuff like this. Okay, so I can say what they say also. I can say what they say. If it is an assignment, rule assignment is assignment, because we are coding C#. J token, so it's an assignment if this application, I'm gonna. Should I? Should I not? No. No, I shouldn't mix the layers like this, or should we each inside the same layer, like, yeah, that's not the layer below, yeah. So I should stick to the I should stick to the abstraction level that I've chosen, and I've chosen that this is on the same level as this. So it would be a bit weird if I would use that, right? I think so, sure. Wow, yeah. Oh wait, the LSP has a form of buffer, yeah. Wow. If op is defined, or maybe I should, yeah. I should have something like this operator, J token, or is operator, yeah, string, and then I do this and return this, just get it done, whatever. I don't care, equal token, I need to say to object, again, string. Now I'm starting to speak J token Newtonsoft language. If that is that, okay, do that, else don't say that it is an operation, that is this operation, okay, and now I can say this operation, yeah, okay, good. I keep it like this. Yeah, I think this is a good level of getting the shit done. is operation. I meant if is assignment. Okay, so now I'm gonna eval an assignment. Okay, what they say. Eval assignment that takes a JToken expression. Okay. So now doesn't return anything. Give me this, then I'm gonna say this also takes the environment. Yeah, it's true. I need to drop the first because that's now red, right? I need to say the color basically, so that's like let's see, let's always skip 1. Okay, so that is the this is the yeah, I need to yeah. Okay, so the thing is an array like this, foo is 10. Okay, so I assert basically that there's 2 slots in what you're saying now, and everything has a strong number of arguments basically. So I can say, I think with confidence, this here should be the symbol, although it's an expression right now here, and then this slot, what do you call this? Here, define variable, definition. Yeah, I should do what they do. Okay. I should do what they do. I should make a function called define variable. Yes. Okay, so that takes the variable, which is a symbol, which is for me a string, which is Bobscheme style. Then I have something that is the value. I can't say value. I say assignment AVA definition value. Definition value. Oh wait, eval definition value. So I get what they mean. They extract that. They have functions that do what I was doing just now here. Yeah, they evaluate this and then they say, yeah, define variable. Yeah, definition. Yeah, I'm gonna say okay. Yeah, def whatever, and then the environment. That is I actually don't need that because I'm modifying the global environment now. So yeah, but it also doesn't matter so much. Okay, so what they do is they return us they have a function that returns the symbol. For me, I return a string called definition variable, and then takes the expression. Yeah, so I mean that's making everything super explicit, sort of what exactly the pieces of the code are. I mean usually, yeah, okay. There's value in doing it like this. That is also what they teach you in SICP with the power of naming, giving things a name. Because yeah, tomorrow I want definition variable to work different. So yeah, right now I say okay, that's the second thing in this array. Yeah, and then I'm casting it to a string. And that's my symbol. Yeah, I bet there's nice ways of breaking this. Okay, so that's the foo in. That's the foo in this. And then there's definition value, which is an object. Take a JToken expression, take a environment. Oh, oops. Yeah, then do this again. This time say the expression, and then return eval the expression and okay. So yeah, that's for example the 10 in foo, but yeah, because I'm calling eval, that is of course allowed to be a nested Bobscheme. Can be something primitive, can be another variable. Yeah, can be a symbol, can be a primitive, a string, a number. Yeah, variables don't work right now because they don't have lookups. Yeah, and can be a function application as well. That's Bobscheme code. Okay, about assignment. Yeah, if I would do like usual C# style, I would actually say variable. I would make variables maybe. I don't know. Would I? I don't know if I would. Define variable. Oops. Define variable. I didn't know. That takes a symbol, definition variable, expression, and then it takes a definition value, expression env, and that's it. And I enjoyed quite a bit in Scheme, but in, I don't know, Scheme, yeah, I'm not sure in Scheme, but in Clojure and eLisp, it returns the symbol, and that's super nice. And symbols are strings and Bobscheme, so I'm just thinking about all the ways in which this will break at some point somehow, but hey, return the symbol. Let's see what happens. Okay, so whoa. I'm gonna ignore this env here. I just say I'm augmenting the global env now. Set item, yeah, symbol becomes still there. Symbol, yes. Yes. Okay, the dictionary is now updated, and I return the symbol, which is the thing that I enjoy quite a bit, because I think it can make code quite a bit nicely expressive, where I can just decide to define. That's nice in eLisp, in eLisp config code. I like to do this when I say add hook, for example. I like to inline random the function definition, because if I eval this, it returns the symbol of this function, so add hook will then be the same as if I would have said this here, right? I don't need to define, and then I like it like this. I think that's cute. Yeah, I think that is, do you do that? It's quite strange. In Clojure we have, if you say var, this is like def, that just means you're making top level things, and you never use that inside blocks somewhere. That's like you will get kicked from the Clojure island if you do that. These are only used for top level things and for hacking at the REPL. There's really useful to put them into a function quickly to define some of your arguments, and then you have them globally defined, which is like, yeah. That is another video, I suppose. So now that I have the global env, I also want to be able to look up. Yeah, they have a layer of interaction there as well, where they say if it's a lookup, I think. Self-evaluating, assignment definition. If it's conditional, that would also be another interesting thing to implement. Should be quick as well. Variable, if variable, then lookup variable. Yeah. Okay, I'm gonna do what they do, whatever. It's gonna be a nice metacircular evaluator from SICP. Okay, is at least to some extent. I didn't put this into my eval yet. Okay, if is assignment, then return eval assignment. Oops. Yes, expression and env. Yeah, getting excited. The build-up. So we'll be able to define expected symbol, because when I say definition variable is symbol expression, nee, das hätte 1 weiter. Sorry, that was German. It should have been one further below here. Expected symbol. Yes. Okay. That's good. That's the kind of stuff I expect. Okay, define. Wow. Okay. And now printf. Yeah, foo is 10. Okay. Soon I will conquer the world. Now I can say, okay, if it's if this variable, okay. So it's a variable, 1 sec. Now I need to... Okay. It's fine. It's just Bobscheme. Okay, if is a variable. No, I'm gonna have a function called lookup variable. I'm gonna do what they do. If it's a variable, lookup variable. Okay, it's gonna return an object. Lookup variable. It's gonna take a JToken expression. Oh, how can this ever be? I always say eval with JTokens. No. Wait, then this assignment thing shouldn't return a string. Yeah. I can't return that right now. Eval assignment. Currently I return. But how will it work? For example, in the eval sequence, I say select eval and it returns an object. Yeah, okay. Oh, maybe it's still fine. No. Okay, lookup variable with an expression and an environment. And if writer is still going, maybe this can help me. Nice. Is variable is never used there. Okay, lookup variable. Okay, come on. Yeah, lookup. Do it. Say env get. Try get. Yeah, but I can throw an error if it doesn't. So can I do this? Oh wait, lookup variable. Hey, how does this work for them? Expression. It's always a string now. Or I tell you this is a string as I froze it now. Okay. I just. Yeah, maybe I do this. Say, that's not a symbol. Because this variable. Yeah, okay. Well, I just checked actually. Yeah, I checked this. But it's allowed to be just a string, by the way. Env symbol expression. Oh, should I? What do you see? To object like this. Okay, I'm just gonna do this because I'm gonna be able to say most of the things I need to say in Bobscheme. And this, of course, is wrong. Expression, yeah, this time it was. Don't they have symbol name? Yeah, it's the same. Var name, yeah, okay. Symbol name, expression. Okay, I actually don't need anything else, it's okay. Gonna throw weird errors to the user, which is fine. I think they do something wrong, then it's not the focus of Bobscheme to turn good errors right now. Okay, it's okay. Now we're getting more complete in our implementation. Now I will maybe say define foo to be 10. Okay, and now I can say foo. Yeah, foo is 10. Okay, foo plus foo. That's 120. Okay, what? That's not JSON. Error passing boolean value 0. Was soll das sein? Oh, I need to. Yeah, I was getting ahead of what it can be. Yeah, so there you go. It's JSON. It's JSON data. This is JSON. But it's Bobscheme. There's a new meaning. Well, yeah, the great thing is you can read some JSON data. Now you can ask ChatGPT to make some JSON data. Now you can modify the JSON data, and it opens doors that previously you didn't have. I don't know why do I need to say what you can do? You can do more things. It's not enough. It's better than being able to do less things. Yeah, and there was also a thing. Yeah, now I could. That's so quick to do. Yeah, I guess once you start having a few pieces, then all the rest starts becoming really quick. Is if JToken expression.